How was the Colosseum built? It's time to unravel this mystery. The Colosseum in Rome is not just ancient ruins. It is an engineering marvel that has stood for almost 2,000 years, surviving earthquakes, fires, and centuries of neglect. Modern architects, with their powerful computers and advanced technologies, still study its design with admiration. We can build skyscrapers that reach into the clouds and bridges that cross oceans. But we cannot, in essence, recreate the Colosseum in its original form using the same materials and within the same time frame. This amphitheater is a monument not only to the greatness of Rome, but also to the lost secrets of its builders. Watch the video to the end to find out how the Romans managed to erect this colossal structure in just 8 years, and what 3 key reasons make repeating this feat virtually impossible today. What if I told you that the construction of the Colosseum did not begin with the laying of the foundation stone, but with the draining of a huge lake? The site for the future amphitheater was chosen with incredible political foresight. Previously, it was the location of Emperor Nero's luxurious palace complex, known as the Golden House. Imagine a modern political leader demolishing the palace of his predecessor, a dictator, and building a public park or stadium in its place. Vespasian did just that, but on a scale that shook the entire ancient world. If you were a Roman citizen watching Nero's luxurious lake being drained to build an amphitheater accessible to all, you would understand the symbolism of this gesture. The government was literally returning to the people the land stolen by a tyrant. At the very center of this complex was an artificial lake, created solely for the pleasure of one man. Emperor Vespasian, who came to power after Nero, made a brilliant decision. He ordered the lake to be drained and something to be built in its place for all the people of Rome. This gesture was symbolic and understandable to every resident of the city. The land that the tyrant had usurped for his personal needs was returned to the people in the form of the largest amphitheater in history. Thus, from the very first day, the Colosseum became a symbol of a new era, where the government serves the citizens, not the other way around. The political context was critically important. Nero seized a huge area in the center of Rome after the Great Fire of 64 AD, evicting thousands of residents. His Golden House occupied about 120 hectares, an area that could accommodate entire neighborhoods. The artificial lake at the center of this complex was a particularly offensive symbol of extravagance, as fresh water was a precious resource in Rome. Vespasian, founder of the Flavian dynasty, came to power after a year of civil war and needed legitimacy. The decision to return the land to the people was not only an ethical gesture, but also a brilliant political move that strengthened his power by demonstrating the contrast with the previous regime. Drainage required a titanic effort in advanced engineering solutions of the time. The Romans dug a whole network of underground channels and collectors to drain water from the lowlands into the Tiber River. It was a large-scale infrastructure project, hidden from view but absolutely necessary to begin construction. A massive concrete foundation 13 meters thick was laid on the dried-up lakebed. This solid foundation had to withstand the weight of hundreds of thousands of tons of stone and marble. Thus, on the site of a symbol of tyranny, a building began to rise that became a symbol of the eternal city. The hydrological problem was complex. The lowland where the lake was located naturally collected water from the surrounding hills. Roman engineers created a system of drainage channels that not only drained the lake, but also prevented future flooding. These channels, some of which are still in use today, were lined with waterproof concrete and had a precisely calculated slope to ensure a constant outflow of water. The concrete foundation was an engineering marvel. 13 meters of depth were necessary to distribute the enormous weight over the marshy ground. The Romans used their famous pozzolan concrete, which could harden even in the presence of moisture, which was critical for the foundation in the former lake. The foundation was elliptical in shape, which was innovative for the time. Most amphitheaters were round, but the ellipse allowed for more spectators and provided a better view of the arena from any seat. The dimensions of the future structure were staggering, 188 meters long and 156 meters wide. Thus, even before the first stone of the facade was laid, Roman engineers solved the most difficult problems. They drained the swampy terrain, created an ultra-strong foundation, and perfectly calculated the shape of the future giant. This was the invisible, but most important part of the work. The elliptical shape required complex mathematical calculations. Unlike a circle, where all points are equidistant from the center, an ellipse has two foci and requires an understanding of conic sections. Roman engineers probably used empirical methods with ropes and pegs to create an accurate elliptical shape on site. The acoustic properties of the ellipse were also an advantage. Sound from the arena bounced off the walls and spread more evenly than in a circular amphitheater, providing better audibility for all spectators. The choice of location was also strategically sound from a logistical standpoint. Its location in the center of the city facilitated the delivery of building materials and access for tens of thousands of workers. All of Rome was to see how quickly and efficiently the new government worked. This first phase of construction demonstrates a key principle of the Roman approach, a combination of engineering power and subtle political calculation. The Colosseum was not just a building, it was an idea embodied in stone, the idea of returning Rome to its citizens. How important do you think this symbolic gesture was for Roman society at the time? Ready to learn the truth about what makes the Colosseum virtually eternal? Its secret lies in the ingenious use of one simple element, the arch. It was the repetitive structure of the arches that allowed the enormous weight of the building to be distributed and created a strong yet elegant framework. Imagine a modern skyscraper with a steel frame, where the weight is distributed through a system of columns and beams. The Romans created a similar system 2,000 years ago, using only stone and an understanding of geometry. If you were an engineer trying to build a 5-story building without modern materials, you would understand the genius of the arch design. It transforms compressive loads into forces that stone can withstand perfectly. Take a look at the facade. It consists of 3 tiers of arcades with 80 arches in each. This lattice structure not only looks beautiful, but is also incredibly functional. It saves material, reduces overall weight, and provides the building with resistance to external loads, such as earthquakes. The main material for the supporting frame was travertine, a durable limestone quarried in Tivoli, 30 kilometers from Rome. It was an expensive and prestigious material that emphasized the status of the structure. Millions of huge stone blocks were delivered to the city and processed on site. The physics of the arch is based on the principle of transferring vertical loads to the side supports through wedge-shaped stones. The central keystone is held in place by the pressure of the adjacent stones, and the entire structure becomes stable only after the last element is installed. The 240 arches of the Colosseum created a 3-dimensional grid, where each arch supported the adjacent ones, forming a self-supporting structure. Seismic stability was critically important for Rome, located in a seismically active zone. The arch structure had a certain flexibility. During an earthquake, the building could deform slightly without collapsing. The gaps between the arches also reduced resonance, which could have amplified the destructive effects of seismic waves. Each travertine block was carefully fitted to the adjacent one. The Romans did not use mortar to bind the supporting structures. Instead, they connected the blocks with 300-ton iron clamps, which were filled with molten lead. This technology ensured incredible strength of the joints. However, in the Middle Ages, it was these metal brackets that caused the partial destruction of the Colosseum. They were broken out of the walls for remelting, leaving characteristic holes in the stone that we can still see today. The logistics of delivering travertine was a huge operation. Stone blocks weighing up to several tons each were transported on special carts pulled by oxen. In total, about 100,000 cubic meters of travertine were needed to build the Colosseum, approximately 300,000 tons of stone. The road from Tivoli to Rome was specially reinforced for these transports. Iron brackets weighing up to 300 kilograms each were made in the shape of the Greek letter pi, P, and connected the blocks horizontally and vertically. Molten lead was poured into special recesses, ensuring a tight connection and additional protection of the iron from corrosion. A total of about 300 tons of iron and lead were used for these connections in the Colosseum. The arch system also solved a crucial logistical problem: the organization of the entry and exit of tens of thousands of spectators. Each of the 80 arches on the lower tier was an entrance that led to a complex system of corridors and staircases. This system, known as the vomitoria, allowed the huge building to be filled and emptied in just 15-20 minutes. The corridors and staircases were designed so that the flows of spectators from different sectors did not intersect. This prevented crowding and allowed everyone to quickly find their seats. Similar principles of organizing the flow of people are still used in the construction of stadiums today. The term vomitoria literally means places of eruption. The corridors erupted spectators into their seats. The system was hierarchical. Each entrance led to specific sectors depending on the social status of the spectator. Senators entered through separate VIP entrances, while ordinary citizens entered through numbered arches corresponding to their tickets, tesserae. Mathematical modeling shows that the system was remarkably effective. 50,000 spectators could leave the building in 15 minutes, a feat that many modern stadiums cannot match. The width of the corridors, the angle of the stairs, the number of exits, everything was calculated with engineering precision. The interior walls and floors, which did not bear the main load, were made of cheaper and lighter materials. Volcanic tuff and brick were used for this purpose. This made it possible to speed up construction and reduce the overall cost of the project. The Colosseum's frame is a perfect example of Roman engineering logic. Maximum strength is achieved through thoughtful geometry rather than solid masonry. It is this combination of strength and elegance that has allowed the building to stand for 2 millennia. But stone alone, even the strongest, would not have allowed the Colosseum to be built so quickly. The Romans had a secret weapon, a unique material that we still cannot reproduce exactly. Are you ready to find out what this material is and why it changed the history of architecture? I will reveal the most closely guarded secret of Roman builders, which allowed them to build for centuries. That secret was concrete, or opus cementicum. But it was not the gray mixture we know today. It was a material with unique properties that only became stronger over time. Imagine a building material that does not degrade over time, but instead becomes stronger with each passing decade. Roman concrete had precisely these properties, which seem almost magical to modern engineers. If you were building a structure that had to last for millennia, you would understand the value of a material that not only withstands stress, but also repairs itself when damaged. Roman concrete consisted of 3 main components: slaked lime, water, and volcanic ash known as pozzolan. It was pozzolan, mined at the foot of Vesuvius, that was the secret ingredient. It reacted chemically with lime to create an incredibly strong and water-resistant composition. Unlike modern concrete, which is simply a mixture that hardens as it dries, Roman concrete underwent a true chemical crystallization. Strong crystalline bonds formed in its structure, making it monolithic. Recent studies have shown that cracks in such concrete are capable of self-healing over time. The chemistry of the pozzolanic reaction was complex. Volcanic ash contained reactive forms of silicon and aluminum, which, when in contact with calcium hydroxide from slaked lime, formed calcium silicate hydrate, a strong cementing agent. This process continued for decades, gradually strengthening the structure of the material. Modern research using electron microscopy has shown that rare minerals such as aluminum tubermarite, which are extremely resistant to destruction, form in Roman concrete. These minerals grow inside microcracks, literally healing damage at the molecular level. This technology allowed the Romans to revolutionize construction. They could pour concrete into any wooden mold, creating complex curved structures such as arches and domes. Previously, this required complex and expensive masonry work with hewn stone. In the Colosseum, concrete was used to build huge vaulted ceilings over corridors and staircases. It was also used to make the foundation and internal structures supporting the rows of seats. This significantly accelerated and reduced the cost of construction. The freedom of form was revolutionary. Before Roman concrete, architects were limited to the rectangular shapes of stone masonry. Concrete allowed for the creation of smooth curves, hemispherical domes, and barrel vaults. Shapes that were not only aesthetically appealing, but also structurally more efficient for load distribution. In the Colosseum, about 70% of the structure is concrete, hidden behind travertine cladding. The rows of seats for spectators, cavea, were concrete blocks supported by a system of concrete arches and vaults. This made it possible to create a complex three-dimensional structure in 8–10 years, a time frame unthinkable for a completely stone structure. The Romans used crushed stone, bricks, or tough fragments as aggregate for the concrete. This not only saved on the main material, but also reinforced the structure from the inside. The result was a composite material that was both light and strong. The technology was simple and effective. Workers mixed the components directly on the construction site and poured the mixture into wooden formwork. After it hardened, the formwork was removed and moved to the next section, which allowed construction to continue without interruption. The Romans developed gradient technology, using different fillers depending on the location of the structure. Heavy basalt was used for the foundation, medium density tuff for the walls, and light pumice for the domes and upper structures. This optimized weight distribution and reduced the load on the base. The reusable formwork system was an economic breakthrough. Wooden forms were used dozens of times, being moved from one section to another. Work crews could work in parallel on different sections, creating a conveyor system for the production of concrete structures. The strength of Roman concrete was such that many structures made from it still stand today without any restoration. The famous Dome of the Pantheon, for example, is still the largest unreinforced concrete dome in the world. It was cast almost 2,000 years ago. The secret of this material was lost with the fall of the Roman Empire. It took humanity more than 1,000 years to reinvent concrete, but we still haven't been able to fully replicate the durability of its Roman ancestor. It was this revolutionary material that allowed the Romans to build quickly, on a large scale, and for centuries. Without opus cementitium, the Colosseum as we know it simply could not have existed. It would have been a long-term construction project lasting many decades. What you are about to learn has exceeded all my expectations about the capabilities of the ancient world. The construction of the Colosseum was not just a building project, but a colossal logistical operation comparable to a military campaign. Managing the delivery of materials and coordinating thousands of workers required ingenious organization. Imagine a modern mega-project, the construction of an airport or stadium for the Olympics, with its Gantt charts, computer modeling, and logistics software. The Romans achieved comparable results using only human intelligence, experience, and strict organization. If you were managing a project that required coordinating tens of thousands of workers without phones, email, or even paper blueprints, you would understand the scale of organizational genius required to build the Colosseum. The main task was to deliver travertine from the quarries in Tivoli. Huge stone blocks weighing several tons were first brought down from the mountains on wooden sleds. They were then loaded onto special barges and floated down the Aniene River to its confluence with the Tiber, and from there almost to the center of Rome. To unload and lift these blocks, the Romans used powerful wooden cranes known as polyspastos. These cranes were driven by huge squirrel wheels, inside which people walked. This system allowed loads weighing up to several tons to be lifted to a height of more than 50 meters. The logistics chain was built with military precision. Every day, several dozen blocks were shipped from the quarries in Tivoli. The 30-kilometer journey took 2 to 3 days, including loading onto barges and river transport. This meant that at any given time, dozens of blocks were on the way, and special unloading crews were waiting for them in Rome. River transport was critical because it allowed the transport of cargo that would be too heavy for land delivery. The barges were specially designed for transporting stone with reinforced bottoms and sides. Navigating the rivers required experience, especially during periods of high water or low water. The entire construction site was entangled in a complex system of wooden scaffolding. The scaffolding was so strong that it could support not only the weight of the workers, but also the lifting mechanisms and building materials. It was a veritable wooden city that grew up around the stone giant. Construction was carried out simultaneously on several sections. To avoid chaos, all work was divided into sectors. Each group of workers, or guild, was led by its own master, who was responsible for a specific type of work. Stonemasons, carpenters, concrete workers. The wooden scaffolding was an engineering structure comparable in complexity to the Colosseum itself. A system of vertical posts, horizontal beams, and diagonal braces created a three-dimensional grid capable of withstanding enormous loads. Strength calculations were made empirically, based on centuries of experience by Roman builders. The organizational structure was hierarchical and clear. The chief architect oversaw the project as a whole, and under him worked masters of various specialties, each of whom managed his own team. The system was similar to a military one, with a clear chain of command and responsibility at each level. To speed up the process, many elements were standardized. Arches, columns, steps, all had standard dimensions. This allowed them to be mass-produced and quickly assembled on site, like in a modern construction set. According to various estimates, between 60,000 and 100,000 people worked on the construction site. These were not only skilled craftsmen, but also a huge number of unskilled workers, many of whom were prisoners. Managing such an army of people required a clear hierarchy and strict discipline. Standardization was a revolutionary concept. Stone blocks were cut according to templates, which ensured interchangeability. If a block was damaged during transportation, it could be replaced with another identical one. This significantly reduced the loss of time and materials. The scale of the workforce was unprecedented. In addition to builders, cooks were needed to prepare food, medics to treat injuries, and administrators to keep track of materials and pay salaries. It was a self-sustaining ecosystem that operated around the clock. To ensure smooth operation, forges for sharpening tools, workshops for stone processing and brick production were organized on site. A system was established for delivering sand, lime, water, and food to the workers. It was a self-sufficient city within a city. The accuracy of the Roman engineers' calculations is astonishing. The huge elliptical building was erected without a single drawing in the modern sense. All calculations were made using simple tools, plumb lines, levels, and measuring cords. This incredible organization and logistics allowed the main part of the work to be completed in just 8 years. This is an unheard of pace even for our time. The Colosseum is a monument not only to architecture, but also to Roman management skills. The calculation methods were based on geometry and practical experience. Roman engineers used systems of proportions and modules, where the dimensions of all elements were related to a basic unit of measurement. The elliptical shape was marked out on the ground with ropes and pegs, using the properties of the ellipse as a geometric figure. But how did workers lift multi-ton blocks to great heights without modern engines? In the next chapter, you will learn about the ingenious Roman lifting machines. The basis of Roman construction power was not supernatural forces, but a deep understanding of the laws of physics. Roman engineers were masters of the art of creating lifting mechanisms. These machines allowed one person to do the work that would have required dozens. The main tool used in the construction of the Colosseum was the aforementioned polyspastos crane. Its name translates as multi-block, which reveals the secret of its effectiveness. It used a system of several blocks and pulleys through which a rope was passed. This system, known as a pulley block, provided a huge gain in strength. The more pulleys there were in the system, the less effort was required to lift the load. This made it possible to lift multi-ton stone blocks with the strength of just a few people. The crane was driven by a large wooden wheel, similar to a hamster wheel, but of enormous size. Inside it, workers walked across crossbars. Their weight and movement rotated the wheel, which in turn wound the lifting rope onto a drum. Such cranes were installed on the upper tiers of scaffolding. They could not only lift loads vertically, but also move them horizontally thanks to a rotating boom. This allowed the blocks to be delivered precisely to their place of installation. In addition to large cranes, many smaller and simpler mechanisms were used. Tripods with a single block, winches, and levers. The entire arsenal of ancient mechanics was employed. The Romans skillfully combined these tools to solve various tasks. Wooden rollers and sleds were used to move the blocks along the ground. To reduce friction, the road was watered or lubricated with grease. It was hard and slow work that required the coordinated efforts of hundreds of people. All these machines were made of wood and rope. Their design was simple but very effective. The secret lay not in the complexity of the mechanism, but in the correct application of the basic principles of mechanics. Interestingly, after the fall of Rome, the technology for building such powerful cranes was lost for many centuries. European builders of the Middle Ages had to reinvent many of these mechanisms. The construction of the Colosseum is a triumph of human muscle power multiplied by engineering genius. It is proof that with the right organization and understanding of the laws of nature, miracles can be created without the help of internal combustion engines and electricity. What if I showed you a time machine that would transport us to the technology of the future, created in the past? Imagine a hot Roman day and 50,000 spectators sitting in the open air. To protect them from the scorching sun, Roman engineers created one of the most amazing devices of antiquity, the Velarium. The Velarium was a giant fabric awning that was stretched over most of the spectator seats. This colossal structure was the pinnacle of engineering and had no analogs in the ancient world. In essence, it was the first retractable stadium roof in history. The structure consisted of several key elements. 240 tall wooden masts were installed along the upper edge of the Colosseum wall. These masts served as supports to which a complex system of ropes was attached. The ropes themselves converged toward the center of the arena, forming a web. Huge sheets of linen or canvas, which made up the awning, were laid on this rope network. A large round hole remained in the center for ventilation and lighting. Controlling this gigantic mechanism required incredible coordination and strength. To do this, a whole team of several hundred experienced sailors from the imperial fleet was recruited. Their experience with sails and rigging came in handy here. Using a system of winches and blocks located on the ground around the Colosseum, the sailors could unfold and fold the awning depending on the weather. The whole process took several hours and was a spectacular sight. It was a demonstration not only of Rome's engineering prowess, but also of its naval power. The structure of the Velarium was carefully designed from an aerodynamic point of view. The shape of the awning allowed it to withstand strong gusts of wind, and the central opening created a draft that ensured constant air circulation above the stands. Even today, creating a similar tent structure for a building of this shape and size would be a complex engineering task. The fact that the Romans were able to design, build, and successfully operate the Velarium 2,000 years ago commands enormous respect. Unfortunately, neither the awning itself nor the wooden masts have survived to this day. However, within the walls of the Colosseum, you can still see the stone brackets that supported the masts and the holes for attaching the ropes. These are silent witnesses to one of the most daring engineering experiments in history. But the most amazing mechanisms were hidden from the eyes of spectators deep beneath the arena. In the next chapter, we will descend into the underground world of the Colosseum, the Hypogeum. What happened beneath the wooden floor of the arena was hidden from public view, but it was there that the technological heart of the Colosseum beat. The Hypogeum is a complex two-level system of tunnels, rooms, and shafts built later during the reign of Emperor Domitian. This underground complex was a true marvel of mechanization. Initially, the Colosseum arena had no basement, which allowed it to be flooded for naval battles. However, Domitian decided to sacrifice this function in order to create a more complex and efficient system. This is how the Hypogeum we see today came into being. The main function of this underground labyrinth was to prepare and organize spectacles. It stored scenery, props, and stage equipment. Along the walls were numerous rooms and niches for staff and technical maintenance. The most impressive element of the Hypogeum was a complex system of lifts and elevators. There were more than 30 such mechanisms, which allowed scenery to be suddenly raised into the arena, creating an element of surprise for the audience. The scenery could change right during the performance. These lifts were in fact large wooden platforms that were raised and lowered using ropes and counterweights. They were set in motion by dozens of workers who turned huge winches in the dim light of the underground chambers. It was hard, coordinated work that required perfect synchronization. In addition to vertical lifts, there were also inclined lifts. They allowed elements to be delivered to the arena from side tunnels. The entire system was designed to ensure maximum spectacle and dynamics of the performances. The wooden floor of the arena above the Hypogeum was covered with sand and had many hidden hatches and trapdoors. At the right moment, the hatch would open, and a new element of the scenery would appear from under the ground. A tree, a rock, or even a small building. This allowed the illusion of magic to be created. A system of tunnels also connected the Colosseum to nearby buildings. There were underground passages leading to barracks, warehouses, and other service areas. This allowed staff and equipment to move around unnoticed by the public. The Hypogeum was a dark, cramped, and stuffy place, lit only by the dim light of oil lamps. However, it was here, in this world hidden from view, that the magic of the Colosseum was born. It was a veritable entertainment factory, operating as a single, well-coordinated mechanism. Today, when we look at the ruins of the Hypogeum, we can only guess at the former scale and complexity of its mechanisms. It was not just a basement, but a high-tech complex that was centuries ahead of its time. Now let's move on to the main question. Why don't we just go ahead and build an exact replica of the Colosseum today? The first and most obvious reason is the astronomical cost. Such a project would cost billions, if not tens of billions of dollars. The main expense would be materials. The facade and frame of the Colosseum are made of travertine. Today, this is a luxury finishing stone that costs a fortune. Using it as the main building material for such a gigantic structure is economically unthinkable. It would take about 100,000 cubic meters of travertine and even more tuff and brick. It would be necessary to reopen quarries and establish industrial-scale stone extraction and processing. This in itself would be a project of national importance. The second expense is labor. The Romans used the labor of tens of thousands of prisoners and workers, which was minimal in cost. Today, such a project would require thousands of highly skilled and highly paid specialists, stonecutters, engineers, architects, and builders. Modern safety standards would also significantly increase the cost and duration of construction. The installation of safety systems, insurance for workers, compliance with environmental standards, all of this was not taken into account by Roman engineers, but is mandatory today. Even the land in the center of Rome, where the Colosseum stands, has a colossal cadastral value. It is practically impossible to find and allocate a plot of this size for new construction in the historic center of any metropolis. It would be the most expensive land for development in the world. Just for comparison, the cost of building modern stadiums, which are constructed from steel and concrete according to standard designs, already reaches $1 to $2 billion. A replica of the Colosseum, with its unique materials and complex manual labor, would cost many times more. Rome could afford such a project for one simple reason. It was financed by military spoils. Construction was carried out using trophies captured after the suppression of the uprising in Judea. In essence, this was money that did not require repayment or economic return. Today, no state or private investor would invest such huge sums in a project that has no clear commercial purpose. The Colosseum was a symbol of the empire's power, and its price was irrelevant. In our pragmatic world, such an approach is impossible. Thus, even if we had all the necessary technology and blueprints, economic reality makes the exact reconstruction of the Colosseum a financial utopia. It is a luxury that only the ruler of half the world could afford. The second reason we cannot repeat this feat lies in the realm of technology and knowledge. Paradoxically, despite all our scientific achievements, some of the secrets of Roman builders remain unknown. We know what they did, but we do not always understand how. As mentioned earlier, the exact recipe for Roman concrete, especially its self-healing properties, is the subject of scientific debate. We can create very strong concrete, but we have not yet been able to replicate a composition that crystallizes and becomes stronger over time using the same components. In addition, we have lost the very culture of working with stone on such a scale. The skills of mass manual processing and fitting of multi-ton blocks without the use of mortar are unique and very rare today. It would be virtually impossible to find enough craftsmen for such a project. The Roman system of labor organization was also unique. It combined strict discipline, narrow specialization, and a huge reserve of cheap labor. It is impossible to recreate such a system within the framework of modern labor legislation and trade unions. Even if we decided to use modern technology, it would not be an accurate recreation. The use of steel structures, powerful electric cranes, and computer modeling would change the very spirit and process of construction. It would no longer be a copy, but a modern stylization. Moreover, modern construction involves a huge amount of bureaucratic procedures. Any such project would require years of approvals, environmental assessments, archaeological surveys, and public hearings. The Roman emperor was spared these problems. His will was the law. The Romans built quickly because they were not limited by anything except the laws of physics. They did not have strict safety standards, environmental restrictions, or the need to obtain dozens of permits. Their approach was extremely pragmatic. The end justifies the means. Their entire system was focused on results, not process. We live in a world where process, safety, and compliance are just as important as the end result. This fundamental difference in approach makes comparing construction times incorrect. So it's not just about money. We can't build a second Colosseum because we are not Romans. We live in a different society with different values, laws, and technological culture. The third and perhaps most important reason why it is impossible to recreate the Colosseum is its unique purpose and symbolism. This amphitheater was not just a sports arena or theater. It was the quintessence of the Roman worldview, the embodiment of the power and ideology of an entire civilization. The Colosseum was built to host specific spectacles that were an integral part of Roman public life. Today, our society simply has no need for a building with such functionality. Modern stadiums are designed for other purposes and have a completely different architecture. We build arenas with ideal sightlines for watching sports matches. We equip them with sophisticated acoustics for concerts, VIP boxes, and food courts. The architecture of modern stadiums is determined by comfort, safety, and commercial efficiency. The architecture of the Colosseum was determined by ideology. Its overwhelming size was intended to demonstrate the greatness of the empire. Its capacity of thousands of people represented the unity of the Roman people, and the spectacles that took place in its arena represented Rome's superiority over the rest of the world. Such a building could only have appeared at a specific moment in history. At the height of the Roman Empire's power, it possessed unlimited resources, the most advanced technology of its time, and absolute authority, capable of mobilizing hundreds of thousands of people to achieve a single goal. The combination of all these factors, enormous wealth, revolutionary concrete, ingenious engineering, and unlimited labor, was unique. It would be virtually impossible to repeat such a combination of circumstances. The Colosseum is not just a building, it is an artifact of its era. Trying to recreate it today is like trying to build a sailing battleship in the age of aircraft carriers. Technically, it is possible, but it lacks any practical or historical meaning. It remains the greatest monument to the engineering genius of Rome. It reminds us of what the human mind is capable of when it is limited only by its own imagination. And that is its main value. That is why we do not build Colosseums today. Not because we cannot physically, but because we are a different civilization. We admire its beauty and genius, but we understand that the time for such buildings is irretrievably gone. The Colosseum stands as an eternal reminder that some creations are so closely tied to their era that they cannot be replicated. They can only serve as a source of inspiration and a silent witness to the greatness of the past. We see that the Colosseum is much more than just a pile of ancient stones. It is the result of a unique combination of circumstances: political will, unlimited resources, revolutionary technologies, and ingenious organization. Every arch and every block of concrete tells a story about a civilization that reached incredible heights in the art of construction. The reasons why we cannot accurately recreate this masterpiece lie not so much in the technical sphere as in the economic, social, and cultural spheres. Our world lives by different laws and values different things, and perhaps there is nothing wrong with that. Do you think humanity should try to recreate the great monuments of the past in the future? Or is it better to focus on creating new ones that reflect the spirit of our time? Suggest topics for future videos that you would like to see on our channel in the comments. And don't forget to subscribe so you don't miss new episodes.